Hopefully everyone enjoys the Adobe Developers live event day 2, and then having a great time in participating in a number of interesting sessions. My name is Maxim Babakov, and I'm a Director of Software Engineering at Balance Chat, which is based off Melbourne, Australia. And today I would like to talk about how to size Adobe Commerce Cloud for a large number of API requests in a headless implementation. The presentation itself will be based on a summary and an example of the headless implementation which we have implemented for 7-Eleven Australia together with Adobe services. And then while the presentation is focused mainly on Adobe Commerce Cloud, however, the similar approach and patterns can be applied for on-premises implementation as well. The implementation for 7-Eleven was an implementation for Adobe Commerce together with IAM using a SIF connector and mobile application via enterprise service bus. The specific of the interest for 7-Eleven is a promotion based on a number of personalized and product combination offers for a different type of the customers. And it's a countrywide, statewide, as well as a store specific, where might be quite a heavy utilization by the customers, and that's been implemented in a way to increase the customer conversion. The external loyalty systems are also in place, like Adobe Campaign. And Adobe Campaign been integrated with a number of cards-related API calls, which are mostly non-cacheable, as they are session-dependent and they quite rely on external systems to retrieve information about the card, about the price, stock. There are a number of heavy operations related to cart operation, like add or removing products from the cart, as well as a number of calls in regards to get the customer, initialize the session, as well as all the heavy checkout operations, which are mostly around recalculation of the totals, payment methods, processing of a number of fraud checks, and creation of the order. Some of these API calls are probably quite tiny and light, and from an execution time perspective, they probably not more than 200 or 300 milliseconds. However, some of the calls might be quite lengthy calls, especially associated with payments or fraud assessment, or might be a calculation of a particular promotion. The longer calls, not that CPU or memory intensive, they mostly are idle for waiting a response from a third-party applications. So the focus of our today's talk will be mostly on estimation of the infrastructure based on the customer interactions or application interactions with Adobe Commerce and the infrastructure itself. And also we will be talking about the number of metrics and methods we could use to validate our configuration, and talk about the specific settings of what may or may not affect the system, and also see if we can align with non-functional requirements. There are also a number of critical success factors which do exist in the application itself. It's make sure that your application is optimized, and make sure that your application is developed in a specific way in order to cater application requirements. And also, there is a number of caching methodologies do exist, which helps you to scale your application. This type of factors we won't be looking in the presentation. So then, talking about what actually responsible for a concurrency execution, or what could be one of the problems which could lead to a bottleneck or problems in throughput of your application. One of the significant one is the maximum number of PHP processes which could run and execute concurrently. Another one which is obviously a different services which your application are relying on is MySQL, Redis, Elasticsearch, or a number of external services which are running in synchronous integration. However, what we did found as an interesting outcome there is the PHP processes was one of the a bottleneck, and that does require quite a careful calculation as well as estimation to make sure that your API calls are executed within a low latency, as well as they're quite self-sufficient from a time perspective, as well as returned and not affecting the application interaction between the client. So the maximum concurrency PHP process controlled by a setting called PM max children. That parameter is defined in a PHP PM config. That setting unfortunately can be managed by a developer itself, but could be changed by creating a support ticket to Magento Cloud team. Then the configuration of Adobe Commerce Cloud, that number multiplies by 2 and by a number of vCPU which exist on front-end instances. For example, if you're running on a split infrastructure and your front-end instances do have 48 vCPU instances, then on that one instance, you could run 96 concurrent PHP processes at the same time. What does that mean? That if your application sends 96 calls at the same time, then they will be processed at the same time. However, if you send 97th call, that call would be queued and will be processed with a little bit of a delay. Then that parameter could be changed, depends on your RAM and CPU utilization, and that could be a very useful parameter in terms of the calculation of what should be a size of your infrastructure, and as well as what could be a utilization of other services which are MySQL or Redis or something like that. It's useful to assess that specific parameter based on your monitoring systems like New Relic, which comes out of the box from Magento Cloud. Then if we look at the problem on a graph size itself, we could see what happens if, for example, you pass the threshold and then you have more than allowed number of child processes. That graph shows that the actual, probably I just jumped one slide. Yeah, sorry. The PHP FPM processes does support a queuing system. And the queuing system basically responsible to queue all the requests which are coming to PHP FPM. The shows like this. The API call comes from a browser or an application to Fastly. Through Fastly, it goes to Nginx, and then it goes to PHP FPM, where you have enough workers, which is your child workers. This is where the magic happens. If you have enough max child workers, that they will be processing your request straight away. However, if there are not enough, they will be queued. And then the setting, which called listen backlog, it basically defines the number of maximum queuing connections. So why queuing is actually good? Because queuing does allow you to cater for spikes of your usual traffic. And then if, for example, you don't have enough capacity to process the call, then it will queue that call and will execute as soon as the PHP FPM worker become available. As soon as that happens, it will be executed. But why queuing is actually not so good in terms of high-load applications. Presume your queue is high enough, and then there are two problems. One problem is that the application itself does receive the response in a bit of a delay. In some cases, it might be quite significant delay, depends on the length of the queue. And then also the services like Fastly, Nginx, and even the browser of a client have the internal time limits. For example, the usual time limit on Nginx and Fastly is around 60 seconds. If that limit passed, then the response back to a browser or to an application would be that, unfortunately, there is a timeout happened and we could not process your request at the moment. And then potentially your application may crash and the user may see quite unpleasant error. Let's see how that actually affects the application. So for example, on the right-hand side here, we used two applications to assess the impact. One was a New Relic to see how the particular request being processed and how long they takes. Another application we have been using OpenSites to see what the timing of a particular request and what's the difference and what the gaps between them. So if there is enough workers, there is no queue type of scenario queued. So we see that every request executed straight away after another. And then on New Relic side, we see that requests are processed quite quickly. There is no spike there. Everything is fine. Let's have a look on a left-hand side. This happens when PHP FPM don't have enough workers to process all the traffic which is coming to the infrastructure. From New Relic perspective, we actually see that nothing has changed. The time of processing the requests is still the same. However, from application perspective, we do see that there is quite a significant gap between the calls. Like, for example, when the user retrieve information about the card, and then the call to update the card, there is a gap of 5 seconds. And then subsequent call, there is another gap of almost 10 seconds. That's actually do affect your application and your customers. However, it's not truly reflected in New Relic, and it's also a showcase of how the PHP FPM queuing is actually affecting our application. Then there are two methods on how you can identify that you actually have an occurrence of queuing of the requests, and there are two methods on you can use which do exist on Adobe Commerce Cloud. One method is PHP PM status page, which you can request to get enabled, and then based on a particular page, you can go there and see the stats of how your PHP PM is progressing. There are a number of metrics and settings you will see there. However, there are two important settings which we need to take into account. One is listen queue. That shows how many requests currently sitting in a queue and needs to be processed by PHP PM worker. If you have enough PHP PM workers, this value should be always 0. Then another valuable thing is a historical metric which is called max children reached. That metric show how many times your PHP FPM actually had a problem where it did not have enough workers. If you see that there is a number more than 0, that's an indication that the PHP FPM workers needs to be increased. Another one which is quite useful notification is a fastly logs, which do available with New Relic logs. There is a value called time elapsed. That value show your long executed requests. That's how you can try to find if your system does have this problem, and then potentially you will also find which request is most longest or been involved in the queuing. Then PHP FPM could be configured in a few ways. One of the ways could be that it could be dynamic or on-demand or static. In this case, we'll be talking about the dynamic and static. By default, the infrastructure is configured in dynamic way, and then this way is most popular one because that gives you quite a balanced configuration if you have any other systems running on the same instance. For example, you have a database running, or you have some other applications which runs on the same instance, and it helps you to save the CPU and memory. But what you may see time to time in the logs that your PHP PM process manager requires to scale up because it don't have enough running instances, or it's already reached a number of instances. Another one is PM static. The PM static gives you an ability to configure your performance on the best performance, and then that means you will have a number of workers which are sitting there and ready to consume the traffic in warmed up state. Let's see what's the difference between dynamic and static in a large scale of requests. So for example, we do have a configuration of dynamic, and it ready to consume 1,000 requests. And then we have static, which also ready to consume 1,000 requests. However, one of the important parts here is how many servers are running at the same time. If you have a process manager configured to run minimum 1 server, or start server is 2, that means your PHP PM server will be sitting there in a kind of non-warm state, in a cold state. So if traffic comes, it will require some time to scale up, and it may cause quite a bit of a latency. If you have a look on the graph here, we see that if the traffic comes with about 1,000 calls at the same time, then the static configuration is able to handle the traffic in a quite a time efficient manner. However, the dynamic does require quite a bit of a time to scale up, and in some cases you may see that the latency might be a second or even more. Then there is a number of simulation models do exist on how you can probably calculate your queue and calculate your infrastructure size. I would do suggest to have a little bit of a study on the queuing theory. In the theory, do consider probably two major options there. One is theoretical, which scenario where all users generating the highest load and do come on the website at the same time. And opposite, which is optimistic method, where we have a continuous uniform probability, where distributions for each of the type of the requests uniform in execution time. The assessment of such optimistic scenario can assist on understanding of the theoretical minimum of the number of PHP processes which do require to process all the traffic with queuing or without queuing. Let's have a look on how to probably confirm the size for your infrastructure in a load test scenario. So in a load test scenario, we do have a number of factors which simulate the way and how the customer interacts with the application. So for example, we have an actor, which is a guest non-competitive buyer. It comes to a home page, it stays there for a random period of time, and then moves to a category page, stays on a number of period of time, and moves to another subsequent pages. And that basically indicates how long a particular user could spend on the website and a time associated with a particular step. Then if we have a look on example on how to calculate how many processes or executors or workers do you need for cater for that scenario. So for example, there are three types of the API calls. The one API type is where your API call consumes less than 500 milliseconds. Another type is less than 1 second, and the third type is less than 3 seconds. For a calculation perspective, we did use that number, 250 milliseconds for first type, 1 second, and 3 seconds for subsequent types, with a duration of the session for 180 seconds. And then we put some number of calls which do require for that session on a particular type. Taking a population of 5,000 calls, we getting numbers where for 5,000 users which do have a session of 180 seconds and they do execute that number of calls per second, it comes to a total execution type in milliseconds of 92,500,000 milliseconds. In order to process all of these in one time without a delay to any of the call, the minimum number of the workers would be 514 workers. If we want to be really on a safe side, we probably take a coefficient and we will multiply this by 2. And that's we will have a number of PHP workers which give us an ability to process all the requests. And then as a result, we will get a number of vCPU instances which do require for processing all the requests. So that number which you need to take into account where you sizing your Adobe Commerce Cloud infrastructure, and that's the vCPU instances which do need to have there in total space across all the nodes. Then the simulation of the load could be run through a number of different tools, and there is randomization needs to be put in place, and you need to make sure that you're running a load generators which are completely separate from each other, and they don't have a network or a power dependencies, and also have a set of tools which do help you to analyze the metrics is New Relic IPM, New Relic logs, or the load testing software, which does extra monitoring tools. Another thing which should be considered as an improvement to a large scale API implementation, that utilization of the API platform architecture, which had been presented by Nishan and Igor earlier today. That architecture gives an ability to process a number of API calls at the same time and would be highly scalable. There are also a number of examples services which already been implemented and run on that architecture is product recommendation or Adobe Live Search is a good examples of successful implementation, which do remove the requirements of a merchant's infrastructure. So just to summarize on what we just talked about, there is a number of key things to consider for maximizing the throughput is make sure that your application is optimized, make sure that you have a sufficient caching strategy across all the levels, you configure your PHP FPM configuration based on your application use case, you are ready for normal traffic or a spike of the traffic, and you take the queuing into account. And then you have a number of tools to rely on, which is New Relic IPM and logs and infrastructure metrics that are best friends in all the journey. And of course, we all looking forward for Adobe Commerce auto-scaling infrastructure being released soon. Hopefully everyone was able to follow in a compressed time. However, if you have any questions, you want to clarify or discuss anything further, feel free to reach me out on Twitter, or I can answer a number of questions right now if you have time. Have a great day, everyone, and enjoy Adobe Developers Live and stay safe.